Adjunct Professor Moran, Microeconomics 112. We're going to conclude our chapter on costs by discussing long-run costs. Average costs are important because that's what's going to determine the price quantity output decision of the individual firm in the short run. Long-run costs, combined with demand, will determine the number of firms in the industry and the size of the firms. In the long run, everything is variable, including your plant capacity, the number of firms in the industry, and so there's no distinction between fixed and variable costs in the long run. You just use an average total cost curve to derive the long run cost curve for an industry. This is what it's going to look like. So we have cost and quantity of output. And if a factory, if an industry, if there's only this much quantity demanded, there may be a lot of firms producing, and these will be their average total cost curves. And they're going to try to get their their lowest point of the average total cost curve to correspond with the quantity of output, minimizing production costs. But as demand grows, it'll justify larger factories, so you'll get a lower average total cost minimum. And this will continue as demand grows. But there comes a point at which larger factories are less efficient. And so the average total cost curve for these larger factories is higher. And the long run average total cost curve is the long run cost curve, is the tangent, is a line tangent to all the minimums. So that's a long run cost curve. Now, the long run cost curve is U-shaped, but not because of the principle of diminishing marginal returns. That only applies in the short run, because the law of diminishing marginal returns states that as you add additional units of a variable input to a fixed plant capacity, returns will increase, then diminish, and then turn negative as you add additional units of input to a fixed plant capacity. That's what will happen to output. But since in the long run everything is variable, there's no distinction between fixed and variable. So what explains this is something called economies of scale. There are many different shapes to a long run cost curve. What explains this decline and then an increase is economies of scale. The benefits of mass production will lead to lower average production costs over a range of output. As companies get larger, as factories get larger, they can afford labor specialization, which reduces setup time and increased expertise at individual jobs. A smaller factory may have to have a laborer work multiple workstations, which he may not do as well, and have to set up and break down jobs as he moves from one to the other. Another advantage of larger economies that gives us economies of scale is managerial specialization. Let's say a manager can supervise 10 workers, but the factory is only hiring 5 workers. Well, that's a waste of managerial potential. So a larger factory that would hire the full 10 workers would be minimizing its cost, because the cost of the manager would be spread over more workers, and as a result, more output. The larger a factory, the more expensive equipment it can buy. It can buy more efficient capital. Larger size enables the most productive equipment to be purchased. A small firm wouldn't bother to buy a very expensive piece of production equipment if they couldn't utilize it fully, because there's no point in spending a lot of money for a piece of equipment that's going to sit idle. You would just use less efficient methods of production. And as these things get larger, production costs will go down, because the cost of an expensive piece of equipment will be spread over so many units of output. One of my favorite examples of efficient capital that is only possible to purchase over large amounts of output is a Versen stamping machine. Bear with me for a minute. Okay, the Versen stamping machine. In 1996, Versen, a U.S. firm located in Chicago, introduced a 49-foot tall metal stamping machine that is the size of a house and weighs as much as 12 locomotives. This machine cost $30 million, and it cuts and sculpts raw sheets of metal into automobile hoods and fenders. If you've ever wondered how cars get the shape they have, the individual parts, this is it. You take steel and slide it in here, and this thing will come down and press it, and it won't damage it, stress it. This piece of equipment enables auto manufacturers to manufacture new parts in just 5 minutes, compared with 8 hours for older stamping machines. A single machine is designed to make 5 million auto parts a year. So to achieve the cost saving that is possible from this machine, an auto manufacturer must have sufficient auto production to use all those 5 million parts. By allowing the use of this cost-saving piece of equipment, large firm size achieves economies of scale. Think about a newspaper. A newspaper used to be able to be purchased for 25 cents. Now, it costs a lot of money to publish a newspaper. There are reporters, there's expensive equipment, trucking costs, but by spreading the costs over lots and lots of produced newspapers, the newspaper achieved economies of scale at a high level of production because they spread those costs out over a large number of output. But now that people are getting more of their news from online, newspapers are selling less and are experiencing diseconomies of scale. They're producing further up this curve, which means that newspapers will become more expensive because the costs of production are spread over fewer units. So General Motors can afford to produce here because they're going to buy a Versen stamping machine and minimize production costs because they're going to spread it over a lot of output. Now, on the bad side for General Motors, before it went bankrupt, was over here. It was experiencing something called diseconomies of scale, where the company is so large, bad things are happening. There were large corporate departments, and they were squabbling amongst each other. General Motors, world's oldest automakers, are aware of the realities of diseconomies of scale. Experts on the auto industry, size may be a liability. It was larger than Ford and Chrysler, and larger than Toyota and Honda combined. Compared with these competitors, GM has a cost disadvantage that may help explain its substantial decline in long-term market share. Despite billions of dollars of investment in modern equipment, General Motors still has the lowest productivity and the highest cost per car in the industry. To reduce economies of scale, General Motors has taken several actions. It's established joint ventures with smaller foreign rivals to reduce its production costs. It's created Saturn, a separate standalone company, and it's given back each of its 5 automobile divisions, Chevy, Buick, Pontiac, Oldsmobile, Cadillac, greater autonomy with respect to engineering, style, and marketing decisions. Most recently, it dismantled its entire automobile divisions. So all that management can be causing diseconomies of scale. So this is economies of scale. As larger output results in lower costs. Diseconomies of scale is when getting even larger, producing more output, requiring a larger factory, would cause higher average total costs. This point here is called minimum efficient scale. It's the first point at which average total cost is minimized. So let's take a look at some different kinds of industries. A hot dog truck achieves minimally efficient scale at a very low amount of output. It makes no sense to have a 2-block long hot dog cart. The guy's running back and forth, not going to work. So you're going to have a lot of hot dog trucks with a relatively high, minimally efficient scale. A car company will achieve minimally efficient scale at a very large amount of output. If the amount of output by which an industry achieves minimally efficient scale is also the market demand, there will be only one producer. The company that gets to this point first, minimally efficient scale, will be able to provide the entire market quantity. It would not make any sense to have two firms up here at a higher average total cost, and the guy that gets here first will be able to undercut this producer. So when the quantity demanded by the entire market, when market demand coincides with minimally efficient scale, there will be a monopoly. One producer. Some firms have something called constant returns to scale. Constant returns to scale. And these the long run curve of these industries look like this. Cost, quantity of output. There will be economies of scale at first, but eventually they reach minimally efficient scale. And then there will be diseconomies of scale. So here, in this type of industry, very small firms can exist with very large firms, because over a certain range of output, the small firm does not suffer a disadvantage compared to a large firm, which in other industries would enjoy the benefits of economies of scale. This would be like cabinet making companies. If you have a small cabinet making company, you got a carpenter with a workbench knocking out cabinets for kitchens. In a large company, they'll have independent workstations for carpenters to do the same. And so whether it's a large company with many independent workers or a small company with an independent worker, they'll enjoy the same costs, minimally efficient scale over a large range of output. Okay. So this concludes our discussion of costs, which are going to be essential to price and quantity output decisions of all types of competition: pure competition, monopolistic competition, oligopoly, and monopoly, which we'll be taking up in the next chapters.